Hello everyone. In this video we are going to discuss about chemical engineering GATE 2020 chemical reaction engineering. GATE 2020 question paper and answer key link is available in my description box. You can download it. Question number 50. The liquid phase irreversible reactions P gives Q and P gives R are carried out in an ideal continuous stirred tank reactor, that is CSTR, operating isothermally at a steady state. Isothermal means constant temperature. The space time of the CSTR is 1 minute, that is tau. Tau is equal to 1 minute. Both the reactions are first order with respect to the reactant P, and K1, K2 denote the rate constant of the two reactions. K1 is the first reaction rate constant, K2 is the second reaction rate constant. At the exit of the reactor, the conversion of reactant P is 60%. Conversion of reactant P is denoted as XP, is 60%. And the selectivity of Q with respect to capital R is 50%. The value of the first order rate constant K1 in minute power minus 1. Objective of this question is to determine the first order rate constant K1 in minute power minus 1. After calculating the first order rate constant K1 value, we have to round up the result to 1 decimal place or correct up to 1 decimal place. Question number 50, data. We have two reactions. First reaction P gives Q, second reaction P gives R. So the first reaction rate constant K1, second reaction rate constant K2. Space time tau is equal to 1 minute. So conversion of reactant P, that is XP, is equal to 0.6. Generally this is denoted as XA. Selectivity of Q with respect to R, that is equal to 0.5. Objective of this question is to determine the first order rate constant K1 in minute power minus 1. Solution part. Selectivity is equal to moles of desired product formed by moles of undesired product formed. From the reaction, desired product is a capital Q, undesired product is a capital R. So numerator moles of desired product formed, that is K1 into Cp from reaction 1. Moles of undesired product formed from reaction 2, K2 into Cp. So K1 Cp divided by K2 Cp. So the common factor Cp. Cp's are cancelled. Finally we get K1 by K2. Selectivity is given. We should take 0.5. So 0.5 is equal to K1 by K2. So from these we are going to frame the relation between K2 and K1. So from these 0.5 K2 is equal to K1. So K2 is equal to 1 by 0.5, that is equal to 2. So the finally K2 is equal to 2 times of K1. So here this reaction carried out in an ideal CSTR. So the CSTR equation tau is equal to Ca0 minus Ca by minus Ra. This is a general equation. Our equation is a P gives Q, P gives R. That's why we should take Cp0 minus Cp by minus Rp. Minus Rp is equal to K1 Cp plus K2 Cp. So that's why tau is equal to Cp0 minus Cp divided by K1 Cp plus K2 Cp. So the numerator part, tau is equal to, what is this? Cp0. Am I correct? So the numerator, this is Cp0 minus Cp. So here what is the Cp value? Cp is equal to Cp naught into 1 minus Xp. So the multiply with the Cp naught here. Cp naught is outside na. Cp naught into 1 Cp naught minus Cp naught into Xp. Am I correct? So Cp naught minus Cp naught into Xp. So this value substitute in numerator part Cp. So this Cp. Okay. So here minus is there. So minus of this value. So what is this? Minus Cp naught. So minus of this value means plus Xp into Cp naught. Am I correct? Xp into Cp naught. So denominator is the same term. No change. That is K1 into Cp plus K2 into Cp. So the common factor Cp mean take outside the Cp value Cp into K1 plus K2. Am I correct? So here K1 plus K2. So which one is cancelled here in numerator term? Plus Cp naught and minus Cp naught. You see here, this is minus Cp naught, this is plus Cp naught. Finally we get tau is equal to Cp naught into Xp by Cp into K1 plus K2. This is common factor, not take outside. Final expression Cp naught into Xp by Cp into K1 plus K2. So this equation here, yeah, Cp into K1 plus K2. So this is the final expression. Tau is equal to this one. So again Cp naught into Xp is a numerator term. Denominator one Cp is there na. So already I said Cp is equal to Cp naught into 1 minus Xp. Substitute here. So the replace Cp naught into 1 minus Xp into K1 plus. So the K2 value already calculated value. This is a relation K2 and K1. So the K2 is equal to 2 times of K1. Refer the previous line. So here numerator part Cp naught into Xp whole divided by Cp naught into 1 minus Xp into K1 plus 2K1. So here Cp naughts are cancelled. Finally we get tau is equal to Xp divided by 1 minus Xp into K1 plus 2K1. So the K1 plus 2K1 that is equal to 3K1. Am I correct? So here Xp value is 0.6. 1 minus 0.6 into 3K1 equal to tau values are given 1 minute. So from these find out the K1 value. So this value come to this side 3K1 into 1 minus 0.6 0.4 that is equal to 0.6. So 0.4 into 3 1.2 times of K1 is equal to 0.6. Finally K1 is equal to 0.6 divided by 1.2. The K1 is equal to 0.5. So answer for this question is K1 is equal to 0.5 minute power minus 1. Answer range is given 0.49 to 0.51. Our answer within this range. Are you clear? Yeah. So question number 51. So here a catalytic gas phase reaction P gives Q is conducted in an isothermal, that is constant temperature, packed bed reactor operated at steady state. The reaction is irreversible, second order with respect to the reactant P. Order of the reaction is a second order reaction. Feed is pure P with a volumetric rate of 1 liter per minute. Volumetric rate means that is V0. And concentration of 2 mole per liter. This is initial concentration. This is denoted as Cp naught. In addition, use the following assumptions. The reactant and product are ideal gases. There is no volume change associated with the reaction. Ideal plug flow condition prevail in the packed bed. So we should take this is the plug flow reactor. Condition is a plug flow conditions. We should take plug flow reactor. So this is assumption. So when the mass of catalyst in the reactor is 4 gram. This is M value. This is 4 gram. Concentration of P measured at exit 0.4 mole per liter. Exit means this is designated as Cp. The second order rate constant in liter squared per gram per mole per minute is Objective of this question to determine the second order rate constant in liters squared per gram mole minute. So after calculating the second order rate constant value, we have to correct up to 1 decimal place. Okay, so yeah, data. So here equation is given, P gives Q. This is a reaction. This reaction is a second order reaction. That's why we should take rate of reaction minus Rp is equal to K into Cp square. Volumetric flow rate V0 is equal to 1 liter per minute. So the initial concentration Cp0 is equal to 2 mole per liter. So assumption is given plug flow reactor. The packed bed reactor, the condition is a plug flow. So mass of the kettle is 4 gram, M value. So the final concentration Cp is equal to 0.4 mole per liter. So here objective of this question is to determine the second order rate constant, that is K, in liter square per gram mole minute. Okay. Solution. So here the condition is a plug flow reactor. So plug flow reactor formula tau is equal to minus integration of Ca0 to Ca dCa by minus Ra. So here minus integration of R equation is a P gives Q na, our reactant is a P. So that's why Cp0 to Cp dCp by minus Rp, that is equal to minus integration of Cp0 to Cp dCp by, what is the minus Rp? Minus Rp already given, that is second order reaction, K into Cp square. So here minus integration of Cp0 to Cp. So this K Cp square goes to numerator, K power minus 1 Cp power minus 2 dCp. So here the K power minus 1 is a constant, take outside. So minus K power minus 1. Here Cp power minus 2. Cp power minus 2 means x power n plus 1 by Cp power n plus 1 minus 2 plus 1. Okay. So divided by minus 2 plus 1. So x power n plus 1 by n plus 1. So here Cp power minus 1 by minus 1. So here Cp this one. Okay. Cp power minus 1 by minus 1. The limit is a Cp0 to Cp. So here one outside one minus is there, divided one minus is there, minus into minus plus. Okay, otherwise minus minus will cancel. So here K power minus 1. So here Cp power minus 1 divided by minus divided by 1 na. So this is can be written as 1 by Cp. Yeah, this value 1 by Cp. So here limit is a Cp0 to Cp, that is equal to, here this is outside, K inverse is there. So here 1 by upper limit minus lower limit na, 1 by Cp minus 1 by Cp0. So this is the integration substitution. So now we know Cp and Cp0 value. This is a given data na, substitute here. So outside K power minus 1 into 1 by 0.4 minus 1 by 2. So the K inverse into 1 by 0.4 minus 1 by 2, that is equal to 2. So here K inverse into 2. This is a RHS side. In LHS side tau is there. What is the tau value here? Generally tau is equal to V by V0. Volume is not here. So here weight is given. So weight or mass is given. Tau is equal to W by V0. So here W is a 4, V0 is a 1. So the tau value, that is equal to 4. Are you clear? Okay. So generally tau is equal to V by V0. Volume is not given here. Weight is given. So that's why we should take tau is equal to W by V0. Why? Because in question itself they have mentioned the unit liter square divided by gram mole minute. So that's why we should take tau is equal to W by V0. W is a 4 gram. V0 is a 1 liter per minute. So here the tau is equal to W by V0. Here 4 by 1. We should take tau is equal to 4. That is equal to RHS side K inverse into 2. So from this, the K inverse into 2 can be written as 2 by K. Na? 2 by K is equal to 4. Am I correct? So the 4K is equal to 2. So what is the K value? 2 by 4. 2 by 4 means K is equal to 0.5. So here the K value 0.5. So the answer range is given 0.49 to 0.51. So our answer within this range, that is k is equal to 0.5. But unit is liter square divided by gram mole per minute. We could check the unit here. Yeah. So tau is equal to, already I said, W by V naught. So the W is a gram. We should take the gram. Is right. So here V naught is a liter per minute. This minute goes to numerator, gram minute per liter. This is a unit of tau. So generally what is a k? So from the relation k is equal to 1 by c into tau. So you could check here. What is a k here? So the k mean this is k is there na. So we want k. So the k is equal to here 2 by 4 na. This 2 is a concentration, that is 1 by c. So the 4 is a tau. So that's why the k is equal to 1 by c into tau. So here what is a c? C unit, concentration unit is a mole per liter. So this 1 divided by mole per liter mean this liter goes to numerator part. Tau, what is a tau? Gram minute per liter. So the numerator liter is there. Liter into liter squared. Denominator mole gram minute. So but our answer 0.5 liter square per mole gram minute. You could check the question. This is right or wrong? Yes. So liter square per gram mole minute. So this is the answer. That is k value 0.5 liter square per gram mole minute. Liter square per gram mole minute. Okay. For further related videos, you can like, share and subscribe my channel. Thank you.